Hello, welcome everybody. I'm back again after the certain technical difficulties with the last stream. I don't only mean the technical difficulties which kept us from getting our hardware example to work, but the technical difficulties as well, which seem to have creeped in, and yeah, it kind of made it unfortunately impossible for you to hear me in the second part of the stream, which is kind of sad. So, okay, let's recap what we have done so far and what I have done in the meantime, actually. Let's take a look at. Okay, this is a lot too bright. You can't even see a thing. Okay, let me fix this. Let me just fix this quickly. I need to correct the exposure level there, which I unfortunately have to set to auto because otherwise it's not working as I would like it to. Okay, so that's not... Okay, I think this is better. I hope this is better. I'm not even sure if it's in focus. I definitely need to get another camera for this close-up views of the hardware when we are doing this in the future more often. So I will take a look at that. So yeah, but for now, this should be sufficient. Let me position it a little bit better so that it's in view. So yeah, okay, what have I done so far? We have the display, an SPI 3.5 inch TFT display we want to interact with. It has a touch layer on top. I haven't even peeled off the security thingy here on top, but I actually won't do this while we are playing around with it, because why should I scratch it? I have an ESP-based controller board here. In the last stream we had another one here. Actually it was this one, the usual dev board, ESP32 dev board. But I replaced it with a TTGO V8, which is essentially a so-called rover board, W Rover. It's essentially an ESP32 with PS RAM inside. So this board here has 4 megabytes of PS RAM, which we can use for example, double buffer or memory for the images we are going to display here. I already said last stream that I might be doing this that way, so that we can have this double buffering there. I'm just seeing there might be a problem with the stream. Let me check. Is it a Twitch problem, or is it my internet connection, or what is it? Something is kind of flaky here a little bit. Okay, seems to work again. So yeah, if you are in the channel and there is a problem, please tell me. The problem with just doing these streams for now, for more or less myself, as nobody else is currently here. I hope this will change in the future. Nevertheless, I will continue to do this as I am having fun, and I would work on these projects anyways, so I can film it. Is that nobody tells me if something is wrong with the internet connection, for example, or the audio like it was last time. So yeah, I hope it works this time. Seems stable now though. Obviously there was some sort of upload problem there, but it seems to have gone now. So okay, yeah, let's actually then. Okay, let's go on. We have replaced, or I have better said, replaced this board with an ESP board, which has PS RAM on it. It's a completely different setup, this board, as they are not using these die package here from Expressive, which is, come on, focus. Which is Room 32. It's the usual package here, the die package used by Expressive and sold by Expressive, but they are using the chip. Oh, now it's not focusing on this one. Great. Hello. Can I have focus, please? Maybe I need to manually focus this because it's not that great working with autofocus. Let me try. Okay, I hope this is okay. They have this ESP32 here, which is actually the CPU itself, and they have all the other integrated logic like the PS RAM and the ROM and stuff like that in different chips on this board. But essentially, for working with it, technically it's more or less the same, so it shouldn't be a problem. So what I have done then, we had problems with getting to work the display in any variety last time. So I've checked up on this actually, and I've found something quite interesting, which I want to show you here. The thing I found out actually was that we are using a 9431 on this display as a controller chip, but we are actually using a different one. This board has the ILI 9488 chip, and that's more or less the main problem we had last time. We were simply interacting with the ROM chip, and of course this did not work as it should have. Let me put the hardware overlay over there. So yeah, so that's more or less the problem. I've done some more things here. As you can see, I have configured in the platform IO ini, which is corresponding to our project, certain compile and build flags. For example, I told the system to use another debug level, which allows us to use debug macros to output to the serial console some information while we are developing. But in the end, we can simply disable it and it will not be compiled in. We have a setting here which tells the board to actually use the PS RAM, which is now available. We have, as I told you, 4 megabytes of PS RAM on this thing. We need to fix a certain thing here, which we need to set with regards to PS RAM, as we can otherwise get some strange bugs. But it's simple to enable that. And then I did something else. As you can see, we have a lot of different parameters here. Last stream, we searched the TFT SPI library on how to configure actually which pins it should use, which driver it should use, and it wasn't that easy to find out. After some more reading of the source code, I simply found out that there are these user setup scripts here, or header files to be precise, and there is this user setup H. And this user setup H, we actually took a look into this last time, but I didn't really grasp what it was for at this time. There are actually all these constants, these preprocessor statements, which we can configure to tell the system what kind of chip it should use, what driver it should use, what pins it should use, in which way it should use the pins. So that's actually in here in this user setup. And there is another file called user setup select. And usually this one is included here, the user setup file. The problem with that actually is that we need to change something inside the dependent library in order to configure our hardware to be used. And I actually don't like that, because if I'm committing this stuff later on to GitHub, and by the way, I said this the last stream in the end, but I think nobody heard it due to the audio problems. I will fully open source all of this work, and I will upload, and as soon as we have something, I will upload that. I will open source the PCB designs we are going to make, most likely as well. I've never designed a PCB, so I'm looking forward to doing so, and checking on and working out with you, I hope, together how this is going to work. And I will upload all that. You will be able to download all that from GitHub and essentially build this thing yourself if you would like to. So to get back to where I was, the problem with this is if I commit this to GitHub, I won't be committing the library dependencies, and it is installed by platform.io. It is simply defined here in the platform ini that it is a dependency with a specific version, and it will automatically be downloaded and installed once you check out the project. The problem is now, if I change something in this user setup file to configure our connection, to configure our drivers and stuff like that, we wouldn't actually be able to we would have a problem because it would be overwritten by the dependency install. And I don't want that. So I've checked other possibilities here, and there is one which is at the top of the user setup select file, which says, okay, here is some constant checked, which is user setup loaded. And it's especially for this case. We can use platform.io. If we are using platform.io, we can define it via our platform.io ini, which is here. And we simply provide the defines as build parameters. We say, okay, user setup is loaded, so the system doesn't override this stuff. And then we configure all these variables here, these macros here ourselves. So we are telling the system that we want the ILI 9488 driver. We have a display width of 480, a display height of 320. We want to use pin 19 for the MISO and pin 23 for the MOSI, which we actually, let me check if I can show you here. There is pin 19 somewhere. There is actually pin 19 and it's not used. So we are actually not using MISO. MISO would be the data output from the display, which we don't have. So this display does not provide us with any output, so we don't need to connect it. But yeah, we are using pin 23 for data input. We have a clock here. We have a chip select so that we could address other SPI things on the same bus. And we have actually the data. It's data connect or something like that. It's a pin that is used by the display to tell when data is transmitted, especially. And we have a reset pin, which is used to initialize the display. We need all those, as well as we are loading a simple font here. The TFT ESPI library comes with a set of fonts we can use, and we are setting a variable here where I have a typo, smooth font, which simply applies some sort of anti-aliasing to the font. If we are using a higher density display, which we are using here for 80 by 320, is quite the resolution for this tiny display. So this should work out nicely. And we, in the end, specify the frequency here at which the SPI bus should operate. We can see later on if we maybe can set this to a higher value, because essentially the ESP32 would be able to put out data faster, but I'm not 100% sure what this display here actually can read, the speed it can work on. So we will see once we have put it all together. Maybe we can make it a little bit faster, which of course would mean we can update the display faster. So yeah, now after I've shown you this, let's take a look at the hardware. I have put all the cables in here. I've connected everything up as it should be actually. Let me try to enable autofocus here again. Maybe it's working now. And maybe we can do something about this exposure. No, that's really much too. That kind of seems to be a little bit better, I guess. It's far from being perfect, but you should be able to see at least kind of what I'm doing there. So yeah, I need to upgrade this camera. So yeah, I've connected all the pins as they are defined in the file you have just seen with the display to their corresponding counterparts. We have here this resistor, which is, I think I put in a 100 ohm resistor. I'm not that sure. It's not even really important what kind of resistance this one has. It's just a current limiting resistor because I'm pulling the LED pin high. It's essentially the pin which allows us to control the backlight of the TFT. So we could essentially control that via microcontroller as well. By sending it a PWM signal, pulse width modulation signal, which then in turn tells it how much brightness we want as it is pulsing the LED backlight in the same frequency. But for our use case, we actually always want the maximum brightness of this display. So yeah, I'm trying to kind of position it here so that you may hopefully see the display in the next segment, because as we have seen last time, I have copied out this example here, which should render us a 3D cube-like thingy. It's just from the examples of the library, and I'm going to put now power into the, where's this cable? It's here. Into the display, microcontroller and display. It's essentially the same power cord. And then we will see if it works. So let me switch to full screen hardware view here. And let me put power in here. And as you can see, yeah, it's actually quite visible on the, oh, that's nice. It's quite visible on the camera. So yeah, we can see that there is actually a cube being rendered on this display. It's kind of flickery. That's something we might be able to fix by putting the frequency of the updates, the SPI frequency up, but we're not going to do that right now. So as you can see, what we actually wanted to achieve the last stream, we achieved now, and it was essentially only a problem of configuration and of setting the right chip. Actually, we would have seen something on the display the last time would we have chosen the correct driver, but we were just talking to a wrong display driver chip, and so of course this one didn't understand what we wanted from it. Yeah, so that's now our basic hardware setup. We can obviously write some data to the display, we can draw on it, and that's kind of some progress we can work with. So let me cut power here again. The next step would be to actually now write some code to transfer some data over there we want to display. I'm thinking about maybe checking if we can just send there like a PNG or so, like over the serial interface, and have it displayed for a first test, because the more I'm thinking about how this should actually work out in the long run, is that I'm thinking about having a controller software on our system, which we need, like like the one the Stream Deck, for example, is using. And it should communicate with our hardware to push the information there on what to display and when to display it, because only the computer can more or less tell what actually the current state is. For example, if we want a button to mute or unmute a microphone, we need to have the state reported of this information from the system. So I guess the display will cache those images and informations. Now, as we have 4 megabyte of PS RAM, this shouldn't be a problem. But the events actually will be set by the software. So in the first implementation run, I guess we will go there and transmit all the image data as well, and just store them in the memory for later usage on the device. Maybe we will be implementing it later on so that we can use the SD card, which is there as well, to store this information, to use it without a computer attached. For example, for controlling some IoT hardware or stuff like that. I'm not sure about that. Maybe I will do that because maybe I want to do that, to use it this way. We will see. I'm not sure. I'm not 100% sure on how we are actually using this and how we are going to implement it. We will just go along and take a look at how it works. So yeah. Unfortunately, before we can start with this, I need to make a really short break, but I will be back in at maximum 5 minutes, I hope. Okay, be right back. So there I am, back already. Let's just drink a little bit of coffee. Okay, so let's take a look at what we are going to do here, or better, let's just do it, I guess. There we go. I hope this is big enough so that you can read it. The first thing I'm going to do is I'm going to delete a lot of different stuff here we don't need from our example. Actually, we don't need this comment. Yeah, we don't need this. It's obvious. So I'm not sure what all this is. It's most likely to be calculate the position of the cube, which we don't need anymore. We don't need certain point structures. We don't need this. We don't need all this stuff. We don't need all these forward declarations. Maybe the setup we need. By the way, as you can see here, I've tested on that the PS RAM is working. We can actually talk to the system to to check how much heap size we got and how much PS RAM we got. And yeah, I've checked this just in order to make sure it works. So I'm not 100% sure why we are actually checking the height and the width of the display here, as we are knowing the display. So yeah, we don't need that actually. So this is something we don't need anymore. Let's remove it, and within the loop we are actually, yeah, render image. We don't even need all those methods anymore. We will shortly create our own just to make sure it works. But yeah, so okay, so that's kind of, that seems to be kind of working. Let's just check that it is actually clearing the. Can we do here something like, is there an, for example, orange? Don't know. Just because I like orange now. Or let's do a cyan maybe. As a lot of my Twitch channels theming is cyan. Okay, so let's just put this one in here. Come on. Yeah, you need to plug it in the right way for it to work. So let's plug it in here and let's upload. Should compile and then upload. Let's do this. Linking, connecting, flashing the ROM. Okay, so yeah, it did. Maybe it's cyan. I'm not. Yeah, it's actually it is cyan. So that worked. That's nice. So yeah, let's get kind of going here. Just it can be hacky at first, and we will be doing here some stuff later on. Hi, Tom is coding. The first viewer here in this channel. Great, I like it. Welcome. Yeah, actually, just for your information, we are currently trying to use a ESP32 to talk to an SPI display which is connected to it, to start building something like a Stream Deck, Macroboard, whatever. This thing has a touch layer on top, which we will hopefully be using, but we are in the first steps of doing this. So yeah, so let's get going. By the way, if there are any problems, if you can't see anything right, or you can't hear anything right, or there is anything not working out, please just mention it in the chat, because it's actually the first, better said, second stream I'm doing, and I'm not 100% sure this setup is working as it should. So okay, let's just with what should we start? We need to somehow pump bitmap information in there. Let's take a look at this library. If we just can write RGB data somewhere onto the screen, then we can just put this one in. Let's check. There are examples here somewhere. They must have something like graphic test. They must have something which is drawing pixel data to the screen. So let's take a look. So yeah, here they are drawing rectangles, circles, rounded. Okay, they are all drawing all kinds of primitives. Flash JPEG. Okay, that's actually quite nice. There is JPEG data there they are using for something, but where they are using it? Rainbow Rainbow might be that they are kind of transferring pixel data there. We just need to know how to transfer pixel data. Set cursor, text color, text. They are actually only, they are rainbow fill. Draw fast H line. Okay, they are drawing lines. Can't we just set some sort of pixel data somehow? How is this cube we had working before actually rendering something? Let's take a look. It needs to process line. It needs to somehow set. Okay, it's drawing lines. This is kind of strange. There needs to be a function to draw pixel. Yeah. Okay, might not be the most efficient way to do it, but I guess that is working. We have a 32-bit color. That's kind of strange. I think we need to figure out what this actually is. So yeah, maybe just how we are going to can we get random data from the is there a chance to get random data from the Arduino platform? I don't know. Let's check. Arduino random. I thought so. So what it is? Okay. It's generating pseudo-random numbers. Okay. Is it? What is it? What kind of number is it? Is it an integer? Is it a floating point? Inclusive random number between min and max. Data type long. Okay. There we go. Data type long. So it actually is an integer. So yeah, maybe we just try this out by looping through the display and telling it that we want to, or yeah, I shouldn't call this X and Y and then use I and J. That wouldn't make much sense. So we know that it is, we can actually use this constant which we defined before. So yeah, and therein, but no, we will render line by line. Y0, Y TFT height, Y++. Let's put that in there. Let's format this file. So yeah, okay, so now we are just doing a draw, TFT draw. It actually has draw bitmap. Interesting. Maybe we can do this a lot more easily. Draw pixel, and we are drawing it XY, and the color is a random. Yeah, I'm not that 100% sure what they have these colors in here. Let's check. TF. There was something like, for example, orange. I just want to see what they are defined as. So it seems to me that those are definitely not 24-bit colors. It's something different. They are using certain. They are using some sort of color encoding. Is there? It kind of looks like a 565 color encoding, maybe, or something like that. I guess they are doing that to limit the bandwidth needed to talk to the display. Is there a is it somehow mentioned in the not really. Is it in the README maybe here? Come on. Where's my browser? I just had a browser window. Okay. TFT. Maybe you need to allocate it. Oh no, bit shifting. Yeah, I'm not 100% sure. By the way, sorry if I'm not that used to looking at the at the chat while I'm working. So might take some time for me to getting used to. No, I guess I can simply put the data in, but I'm not 100% sure what format this color is they are using. I guess that's the thing we need to figure out first before we can put something onto the display. So I guess they are writing it. The library supports wavelength and color e-paper, bit color. Sprites by default use 16-bit colors. The bit depth can be set to colors to reduce. Okay, so there is something like sprites, obviously, which we might use later on. That's nice, but we don't want to use this. Sprites can be plotted, specific, transparent, anti-aliased, color. Okay, that's kind of strange. The documentation of this library is not really good, I have to say. Color format. Maybe otherwise we need to read the source code. Instead of light blue, I get magenta. The problem does not occur when I do the following. Return. Okay, what's he doing here? Okay, that's going to look more and more like 565 encoding to me. Colors are expected to be specified in there it is, 565 format. Yeah, okay. So that means that we have 5 bits, 6 bits, 5 bits. Okay, I can live with that. So essentially, the highest number we want is 60. Yeah, it's 16-bit. So yeah, I'm lazy this way. So let's just have the where's our program? There's our program. Let's just put in there a random between 0, I guess, and our max value. I know this won't distribute the colors in a normal way, but let's just check if it's working at all and draws display to the draws pixel to the screen. So I hope this might work. Let's check. Yeah, you're right, Tom. It's a start, and it's doing something. It's not doing what I was expecting it would do, but it's definitely drawing, yeah, kind of white noise to the screen. Okay, the autofocus isn't working at all, but yeah, it is doing something. Interestingly enough, it's not addressing the whole display, which is kind of strange. Okay, let's tackle that one first. We are going the Y is the height. It's okay, and this is width. We are setting the rotation here. I guess that's the problem. So I guess that this is then applied to the rotated screen. Let's just remove this rotation and test again, but I would assume that this is working then, hopefully. Let's see. Maybe I can't I put this camera? Yeah, now it's Can I put this so that it's more clearly visible here? That's not really getting better. But yeah, it's not. Why is it not focusing? I guess there is it's the autofocus not. Ah, that's better. Now it's focusing. So yeah. So we are drawing in the wrong. Okay, it's that's kind of interesting. It's we are drawing the in a vertical manner, not in a. I guess this display is. That's kind of irritating. Why is it doing that? Am I? Wait a second. We have this auto loop, which is doing the height, and we have it that is the width. Are we? Wait a second. Let's just try to color each line. I can't believe that this is 480 and this is 320. That would be kind of strange, I guess. I'm not sure. Okay. But it's fun figuring all this stuff out. Never actually worked with an SPI display before, so and haven't done this kind of ESP programming for quite some while. So it's fun. So let's just maybe set the color here, which was I guess a uint 30. What is the definition here? Yeah, it's new in 32. So it's not. It's what am I doing here? So yeah, let's just do this, and then we have a random value here. Let's take this random value and put it there, so that we have a random value. I've now deleted this one. Yeah, it might be the default orientation. Yeah, the constants actually are the ones I've set according to the display used. So this is actually the hardware specific configuration for this for the display itself. So yeah, but maybe we need to check this. I want to. It really looks like it, but I'm kind of confused. It really looks like it has 480. It has 320 in this direction and 480 in this. Or have I set the constants wrong? Width is 480 and height is 320. So yeah, maybe it is like this. Let's just check what happens if we do this. And no, I didn't want to open the Swagger preview. I wanted to upload the sketch. Okay, it's flashing. So okay, now it's really putting differently colored lines onto the screen. It doesn't make sense at all to me, but it looks like okay. It's kind of a strange thing to see, actually. What if we do it this way? Then it should fill the screen with a different color each time, I guess. Each run? Not sure. But yeah, it okay. That's really strange. Somehow I don't And I just realized that I'm not showing you what I have what I have changed the whole time. Sorry for that. Just getting used to this. So yeah, I've now put the color here outside of the loops so that it should each iteration just fill the whole screen up with a new color. Yeah, thanks for coming by, and yeah, hopefully we can do this again. So okay, so let's I'm still not sure why and what this is, what is going on here. So let's find out why. Well, it is so it is drawing. At least we got something that is drawing here, which is quite nice, but I'm not 100% sure how this display is oriented. So I need to somewhat, yeah. There I have it. Just dropped my ring, which I'm always playing around with when I'm thinking about stuff like this. Okay, so we are actually, this is X and Y. Okay, I see. So so I guess we could, but no, we are actually, the height is 480. Wait, the height is 480? Okay, that's what? TFT width is 480 and height is 320. So where is this information coming from? Where is this? Where's this defined? Okay, it's okay, I see. It's defined in. Okay, so this chipset, this ILI 9488 is. I see. Okay, that makes sense now. It is actually completely ignoring what we put in here, so I should be able to delete it and it should work nevertheless. Let's compile and let's upload and let's see. So I guess this is a portrait mode display. So if we want to, yeah, okay, it simply is a portrait mode display. So it's actually doing the right thing. I was just confused by having defined other, yeah. Okay, so we should be able to actually, change this by using this rotation. Set rotation. Maybe we should take a look at the definition of this one. Rotate the screen orientation. Is there anything else here? Yeah, it's let's check for our driver. It should be here somewhere. There it is. So we don't want portrait. We want landscape. Portrait plus 90. Yeah, sounds good to me. So it is simply then rotating the, I get it. Okay, so if we are using the constants, this will not work. But if we are, if that is most likely why the sketch before saved the screen size somewhere. So there was something like a hide function, which, what is it returning? I just don't know the names. It's an int16t. Okay, let's just get an int16, and this is the height, and we have the width, and we store this for now. This is, I know this is quite hacky what we are doing here, but we can clean it up later on. So we want to do this, and we want to do this, and now we want to set this, and we want to get the width, and no, let's just let's maybe hey, width, there we go. So, and let's upload this one, and then it should hopefully update the pixels in the other, oops, sorry, in the other orientation. Yeah, okay. So this is working, that's nice. So now we have figured out this orientation stuff. Let me just put a comment here to ensure that we know why we did this. Display usually is a portrait mode display. Setting it to landscape. So by the way, now I realize what Tom was saying with its you are using constants, so it might just be the default orientation. Yeah, that was what he was going to tell me. It's really kind of hard to do the streaming and concentrating on development at the same time. But I'm quite sure I will get better at this. So yeah, okay. So now we are filling the screen. So now we can actually draw pixels. I would very much like to somehow put an image on screen of this display, even though this is really slow. And I'm thinking if there is some sort of, it seems to really draw and transfer each pixel. It might be, there might be, yeah, they are doing something like begin TFT right here. We need to definitely check out if there is a certain way of drawing it in a more efficient way, like putting it all there and then sending out in chunks. But we will not think about this now. So let's check. I guess there was maybe the most easiest way of doing this would be to simply feed it a PNG or maybe binary data. I'm not that sure yet. But yeah, we could do this. Let's see. No. I guess we need some way of feeding it data from the outside. What's the most easiest way to do this? Like we could use a serial connection, I guess. We could just read from serial and just plot it to the display. So let's check on how to do this. I think there was something like, it was called, I used it a long time ago. I know that it was from Spacehoon, like simple C. Ah, there it is. Simple CLI. That's actually a very small library which allows us to kind of define commands and transfer them via serial. I'm not 100% sure if it's a little bit overkill for what we are going to do, but actually, why not? So there is a simple example. Boundless command, help command, video example. It's kind of ping pong, add argument, add flex. Maybe I should make this a little bit bigger so that you can read it as well. Okay, so so maybe this is a little bit much here. Maybe we should. Maybe we for now we should just pump in the raw data. But on the other hand, we will need something like this anyways. So let's install it. Let's go to platform ini home. Let's projects, stream thingy. By the way, I've decided to rename this thing not to stream thingy, but to I guess Macroboard will be the new name. Yeah, we will see. So where are our library configurations? Libraries there. Add library. Simple CLI. I guess it will be in the I guess it will be in the platform. Yeah, there it is. Go edit. There we go. Now we have that. Save. And I guess we need to install it now. I'm not sure that it is actually... okay, it is installed. Okay, so we now should be able to access it. Okay, so let's take a look again at this thingy here. Maybe we do what I always do in those situations when I'm not absolutely sure. I just copy the stuff and take out what we need. So obviously we need some sort of header files for this, and we need an object for this, an instance of the class, and obviously for each command it seems to be there needs to be some sort of command. So let's just do command render PNG, something like that. Render image. I'm not 100% sure. We can. So error callback would then be CLI error callback. What does it do? Okay, it yeah, seems to be quite usable, but we most likely need a forward declaration of it somewhere, so we can do this directly. So yeah, what do we have here? Pong callback, we just deleted this one. Ping callback, which is actually something we might... That seems to be that it calls a callback every time we want to, or a command is received. So let's then do this. That would be render PNG callback then, and we get a pointer, and we are wrapping this one in a new command instance. Okay, on the stack. It's kind of interesting, but okay. So then it does some sort of command handling. Okay, let's take this information here and put it into our initialization here. It should be there, I guess. And this one will be render PNG, CLI add command render PNG, not ping, but PNG. And there we go with our render PNG callback. Do we actually want add positional argument? Add positional argument. Add boundless command. Not sure what a boundless command is. Maybe we need to read the documentation regarding this. So this should, with having to look up this stuff here, should actually register this thing. This is something we need to take care of as well. So yeah, we don't need this. And there we are reading from serial. We are taking this and putting it within our, where is our loop function? There it is. There is our loop function. So let's actually do it this way. Let's put this here and let's just make a block scope there. Don't really know about this, but we will clean up anyways. So, okay, until a new line is found, and then, yeah, but that is not, I guess that is not working out for us anyways, because there might be new line characters in our binary data. So this might be kind of tricky. I mean, we might have them encoded in base 64 or stuff like that, but I mean, okay, I guess we will. I guess we will not use this CLI stuff yet, because we just want to read binary data here. So let's just. I mean, it won't hurt us to have this code there, but yeah, but we won't use it yet, I guess. So let's do it in another way. Let's just okay. So we are doing the following. We are reading an image size, yeah, which actually is a string then, but okay. So, and we are reading until new line, and then we can say, okay, waiting for image data size. Image size, there we are. So yeah, let's check this. We don't want this. So now we need to somehow, is there an A2I or something like this? Actually, X1 A2I R. We need a A2L. Is it? Is it? It would be A2L. We need a long here. Okay, so. Long image size, let's call it L image size for now. I'm not really happy with this, but and we can just get the C string of it here. So yeah, this should work. So now we should have the image size, and now we should be able to actually allocate the image size in the PSRAM, but I have no idea how to allocate memory in the PSRAM. So PSRAM ESP32 alloc. Better said, malloc is what I'm searching for. I guess there will be something like a malloc PS. Not sure. Heap caps malloc. No, that's not what we are searching for. Arduino, because we are using the Arduino library. Heap caps mallocs. How to use PSRAM with Arduino JSON? Yeah, no. Use PSRAM. PS malloc, maybe? If you're new to Arduino, no, yeah, but it seems to me that we want to use PS malloc. So let's take a look at this. Let's just create, or let's do byte pointer, PS data, PS malloc. Seems to be there actually, so we want to allocate the image size we've just retrieved in the RAM so we can read into it, and we want to cast it to a byte pointer because so yeah, if PS data is null, we actually should a serial print line could not allocate PS memory for data. And I guess we should maybe store this pointer outside. No, it does. We don't care actually. And in this case, if this happens, we actually want the ESP to restart. Maybe we want to wait like 300 milliseconds or stuff or something like that, and then we want to restart it because at this point something has gone horribly wrong, and we want to just restart the microcontroller. This should not happen. So let's take a look here. What are we going to do now with it? We have this memory allocated, so now we need to serial.read bytes. And we want to read into the PS data buffer. And we want to read. Yeah, essentially we now want to read L image size, don't we? I guess so. So I have no idea if this works, but let's try. So, and even though we are not yet rendering anything, but I could just serial print line the PS data after we've read it. Matches the argument. Okay, it doesn't like. Yeah, I guess as we are not defining what we have in there, I can do this. Should be fine for now, just to test it. So maybe we disable this for now. Okay, let's upload. Let's upload and take a look. Okay, something happened. What did I do wrong? Render PNG callback was not declared in the scope. Yeah, of course it wasn't, because I haven't a forward declaration of it. I'm not even really using it, but nevertheless, as I have the code in there. Whoops, that was not what I wanted to do. Now let's try again. It's linking and it's connecting and it's uploading. Yay! Upload! Okay, so terminal will be used by tasks. Yeah, nice one. So now I want the serial monitor, I guess. Can I actually... Can I actually... What if I now do 30... Can I use this one? Okay. So that's not what should have happened, actually. Okay, if I do now 4, but I haven't yet pressed enter, why is it... And then why is it giving... It is rendering garbage because there is garbage in the where the pointer should be, but it should have read the... I'm not that sure that this is working as it should. What is this actually doing? Okay, is there an easy way to just send image data via Arduino serial send data? No. Serial send data to ESP32 or something like this. Maybe serial talk, sending data from ESP. Yeah. I'm just about to open a Wi-Fi there and then adding an HTTP endpoint. if I can't get this serial stuff to work, I could simply transmit it via HTTP. It might even be easier, actually, because that's kind of I know how to do, or that's easy to do, to simply have a web server there on an ESP32. How to send data to the serial console. This kind of looks like what we want to do. Picture things quite well written. Thank you. No. Okay, maybe it's a platform IO send serial data thing. Is there a way to send manually typing messages to Arduino? Send string to Arduino over serial connection. I have something in my memory about having to configure it kind of to adhere to the new lines and only send once you have pressed enter or something like that. Cool term. No, I mean I could use screen to connect to this thing, but I guess I'm just using this function wrong. I guess it's then reading the serial in one go, or it is not waiting. It is simply reading it. This will be quite complicated to implement. I'm not sure I want to do this actually. Can we just let's check. Can we use send data to serial from shell script? Can I use cat for that, or screen or something like that? I just want to kind of send data there. Yeah, that's what actually I hoped. Okay, this would work. Bot rate. Yeah, might not need before I start. Okay, we'll use stdin as default file descriptor to effect. So, okay. Yeah, I know that screen will work. So yeah, I should make it a little bit bigger. Yeah, I guess so. I guess that might work actually. Let's just kind of test it here. Let's just do an yeah, stdy96 def USB. No, it's def. What was it? What's used by this thing here? It tells me where it connects. I'm not 100% sure on mini term. There, this one. We want this one. Yeah. Okay, so, and now let's just echo. Maybe we. Can we read it after that? Okay, let's just do something like echo 100 to just to test, and just put it there, and then we need to read it, of course. Cut def. I can't believe that this would work. Let's just put it in the background and then echo this again, and okay. Okay, so it is actually doing, let's maybe 10, and then let's echo 1, 2, 3, 4, 5, 6, 7, 8, 9, and maybe not with the new line at the end, because that we don't expect that there. Let's just check what happens if we send this to the serial port. Doesn't work out as I hoped it would. Yeah. Not working out as I hoped it would. Most likely needs to be in one chunk of the. Okay, I guess this is not working out so well. So I guess we could just, maybe it's easier to simply do this by HTTP. ESP32 HTTP server. It's the async web server. I mean, we need it anyways at some point. Simple, or hello world example. Asynchronous web server, there we go. The libraries, the code. Yeah, we need the async web server thingy, I know that. Okay, so let's start by kind of cleaning up here again. We have made quite a mess. So I will be removing this, and I will be removing this, and I will not be initializing this. I can remove this, this, and this. So yeah, we won't use this simple CLI thingy. That's something we might kind of have there. We don't need this. We don't need the PNG callback anymore. Okay, so we have kind of removed everything that we had in there before. Okay, so now we need the platform IO home projects string thingy library, and we need this async web. No. I don't want to change this. I didn't want to do this. Damn. Home projects configure. There we go. The library. Yeah. Add library async ESP async web. But I think it was called async. Okay, async web server. Is it this one? Minodef. Let's just check. Is it really ESP async web server? Yeah, it is this one. Okay, so we will need this one. Install it. And there we go. Yeah, I guess this should be quite easily. By the way, this is something we could do. We could bump our serial speed a little bit. Already there, it's 1152. Should be no problem. So, okay, but let's check this here. So, what do we need? We need include ESP async. Oh, ESP async web server age. ESP async web server age. Why isn't it there? Because we haven't saved this yet, and so the platform ini system wasn't able of installing it yet. There we go. So now we have it there. We obviously need, we need a SSID and a password. No, we won't do this. We will simply have this ESP open up its own Wi-Fi. Yeah, that's something we have to look up. ESP32 create Wi-Fi. Exactly, access point mode. No, I don't want to. There we go. Okay, so Wi-Fi. Okay, so include Wi-Fi H, and then yeah, I guess we can. Trade access point capabilities. Yeah, we there's a lot more in here that we don't need. We actually need not many of this stuff. We need the SSID and password. We want this thing to do so. Yeah, we can actually call it ESP32 access point. I don't care. The password is okay as well. AP opened up by ESP32. So we don't need the Wi-Fi thingy there. Yeah, this is something we need. At least part of it. Remove the password parameter. Okay, we can actually that's nice. So we don't need that, as it is just for testing. There's nothing anybody could actually do with that IP address. Yeah, okay. I guess you can caps lock it all the way through, but yeah, we don't want the server to start there yet. Isn't for incoming clients. Yeah, we can. No, go back there. We can, and we should do this. If there's a new client, can put a message other than the serial, make string hold incoming. Do we actually need this? Wi-Fi client, server. No, this is actually not the Wi-Fi handling. This is actually the HTTP handling, and we are doing this with... okay, so essentially we should have set up Wi-Fi by now. Set up Wi-Fi. Check PS, RAM is working, initialize serial. Yeah, this kind of obvious that we are initializing the serial there, but okay. Let's just set up SPI TFT. So, okay. Now in the loop, we want to do the following. We want to go back here and take a look here. We need this async web server, and I guess we will have it here. That's our async web server. Nice. So now we need something like okay, so it seems to me that this is our okay, let's do it here. Configure web server, or better initialize web server, and we will put this there. Yeah, it's actually a lambda. Okay, so yeah, just for testing purposes we can have it this way. So I guess if we don't need to server begin, okay, we need to server. As it is async, it most likely will somehow register as a task in the background on the ESP. So, okay, let's do this and let's check loop. We will uncomment this here. So let's comment this out. Okay, this didn't work at all somehow. Why did it not? There's something strange going on here. But I guess it's just a highlighting problem, I guess. So let's compile this. Try to compile it. If it's a real problem with the code, it won't compile, but it looks like it. So yeah, let's try this. It's writing. Our image, of course, got a lot bigger now because we have all this Wi-Fi and web server stuff in it. Okay, so now we should be able to get information here about the Wi-Fi, which was just opened. And no, I should actually... Yeah, I changed the communication speed, but why the hell did I do this? So if I'm doing this, I need to do it on the other side as well. That wasn't a good idea, because I actually don't really know how to do this. It can't be that hard, but yeah. So how big is our image actually? We have, what has he built here? Oh. Okay, so if I get this right, I should actually be able to connect to this Wi-Fi. No? Shouldn't there be? Maybe I'm not. Other networks. ESP, access point, connect. Okay, we have actually connected there. So let's check the IP of our Pi of our ESP was this one. I have no idea what kind of IP I have been assigned now. There is no DHCP or something like that, but let's just check if we can communicate. We can communicate with it. So let's just send a curl there. Get slash what was it? Hello. And we get our response back. Okay, that's actually quite nice. That's a lot better for now than what we had before with the serial thingy. So, okay, so now we should be able to take this a step further by having a route which actually takes an image as data. Shouldn't be that hard now, I guess. Maybe, we will see. So let's call it render, or maybe let's not change this one so that we have one to check with, and make a render. Let's make a render color for now. So this one will be a post, and we need to take a look at how this is actually working out then. So I actually don't really like the way the auto formatter formats this, but okay, I won't complain yet. So what we are going to do is we will have something like an int, a uint 32t, which is the fill color maybe, and it will be TFT cyan by default. So now we have a loop here, and we can kind of remove all this stuff shortly. So yeah, we will have a loop here, and we will let me think about this. I guess I will simply have something like tft.fill screen fill color, and then we will simply kind of wait like, I don't know, 30 milliseconds or 16, 16.6, 17, should be 60 FPS then. Okay, so so now we can remove all this stuff. So it's just always setting the fill color, and our render color function now should actually take this new color somehow out of the request it is getting. Does it have something like a body or read? No. Okay, I guess we need to check up on how to read a post body. ESP async web server read post body. Supporting results server arc plane with a plane body of the post request. Another thing, the request plane body comes in pieces in async while it's collected in the regular server. Those pieces are collected through the on request body callbacks. Okay. Oh, somebody know I've got I didn't know second, third callback. I will close the issue now. Okay, so body data handling. Let's take a look. How is this done? Handle body. File upload handling? No. Get post and file parameters. Okay, we can actually. Yeah. Okay, let's do it. We need post body handling now, but let's check if we can simply access some data from. I know using a GET request as an operation to change information is definitely not what you want. But let's check if we can actually get this one. Has param color. We will do a fill color is A12 request. Was it get param? Get param color. Actually, this shouldn't work in C. I'm kind of confused, but it needs to be this way. It needs to be double quotes. Okay, so, and maybe we should else serial.print print line. I hope I'm not slipping to my native tongue while I'm actually talking while coding. If so, please tell me. So let's have a print line. Render color without color parameter given. So okay. So now we will serial dot, not punkt. Punkt it would be in German, but no. Serial dot print line. No print. Rendering color. And then we will do a serial dot print line. And we simply put the fill color in there, I guess. Yeah. Yeah. Okay, let's try it like this. Let's try it like this. Okay, that does not work because cannot convert to const char for argument 1 to what? Wait a second. What is this? What is this providing us? It's an async web parameter. So what is an async web parameter? I would have assumed that it is a. Okay. Is it? It's not a template thingy. It's. I see. So we are going to get the parameter and we are going to get the value of that, and then we are going to get the C string of that. Kind of messy, but maybe it works. Let's try this again. Okay, not working as well. Base of operand has non-pointer type string. Yeah, that's right. That's right. So wait a second, but this isn't a pointer type as well then, so. Okay, let me check those. Oh no, we are getting a pointer back here. We are getting a pointer to the back. Yeah, that kind of makes sense, as it will be the same
position in memory. It won't be copied around. So yeah. So the Wi-Fi is reconnecting and the Wi-Fi reconnected. Nice. So now we got this. It's still working. So if I now do render color, and I should actually have. Can I? I think I can split this here. Yes, I can split it. And I want. No, I should tabs. Yeah, exactly. I don't want this one. I want. No, I don't want the upload task as well. I want the serial monitor, and I want this one. Yeah, I want this one there. No, Yes. Yeah. Okay. So now we see actually what we are doing there. Let me put this. Or maybe we can just tell the system to not. No. That's not what I wanted there. How do I remove the tabs again? Okay. Not so important. Let's clear this one. And now let's do curl with the hello. Okay, that should do nothing. But if we do render color here, it should give us an error without color parameter given. Okay. And okay, we don't response. We don't have a response. But if I do here color, something like this. No match found. Okay, because I get it. Because because the question mark is not. He doesn't like the question mark because the bash expands it. Rendering color 0. Okay. Yeah, empty reply from server. We can easily fix that, I guess, by simply doing. By simply doing a request send. Is there a send 200 text plain just for the header, and then rendering color. And in this case, we might actually send the 500 with exactly this text. Yeah, why not? So this should actually work then. I guess the mapping here is not working yet, but let's check this one out. The color linking. Maybe we won't be playing too much with it. I just want to make sure that I can somehow put data there via request, and it seems to work. So that's quite okay for now. And we want to send images, for example, there anyway. So maybe this can be a lot easier. So let's just check here. Okay, strangely there is no response. Why isn't there a response? Do I get the hello? I get the hello, so the system is there. Do I get the error response? I get the error response, but I do not get... That's kind of strange. So maybe 1, 2, 3, 4, 5. Rendering color. Okay, so it didn't it didn't like my my syntax there. Yeah, of course it couldn't parse it. Yeah, I used A2L, so yeah, okay. Yeah, but as you can see, it is changing color here. I like that, actually. Of course, we can't put in really real essential color values here now, but for test it is completely enough. So yeah, it seems to be working, and I really would like to, maybe what we can do this time, we won't, I guess we won't be getting to the point where we are rendering images yet, but maybe for this time we can actually go ahead and go to the point where we pass some body data, which we can then render. Wouldn't be that bad, actually, and shouldn't be that hard, because I've only got limited time there, and we are already near the 2-hour mark, so yeah. Let's let's take a look on how to parse body information. File, or maybe we want to handle file upload. We want to upload it, but I'm not sure. I think we want to simply handle body data. I guess, yeah, kind of. If you need JSON body handling with Arduino JSON handler, REST endpoint, request, JSON variant. Oh, wait, endpoints which consume JSON can use a special handler to get ready to use JSON data in the request callback. Okay, that's kind of nice. Maybe we should do this, starting with it directly and talk JSON. Because it seems to me that it is ready for usage, and just using Arduino JSON we can get the data out of it. Async web server request, JSON variant, JSON, and it seems to me then we get this one out there. Okay. Yeah, that's kind of, I'm not sure. Set large web page from procmem. No. Okay, so JSON body handling with body data handling. Handle body, async web server request, data, size, index, total. Body start, total. Serial write data. Yeah, that's essentially index plus len. Yeah, okay, I guess it will be then put there in chunks, which is okay because it is streamed in. That's essentially really what we want. But how do we attach this parsing to a specific request? I don't want to do it. I don't want to do it always. So wasn't there a mention of this thing here? Those pieces are collected through the onRequest body callbacks. Let's take a look at this. Okay, started, finished. Can I get assume, but you know, I've got the things. Okay, let's take a look. Async web server body parsing. Handling body data. Is this something? Okay, so on post. I see. Okay, I can give it another handling function there. Body handling function. Yeah. Okay, using lambda syntax. It's quite well and quite nice for me. So I guess this is the start of the request or something like this, and this is the handler for the chunk. But yeah, okay, that shouldn't be a problem at all. So then we should be able to create something like this. Render. Yeah, let's. I'm not sure it can distinguish between this, but let's check this one. Let's check it out. So we can remove all this, and can we have a signature on that, please? Okay, so there's the URI, there's the web request method composite, on request handler function and on upload function. Okay. So it seems to be that we are overriding we have the URI, then the method, then there's the handler function. So, okay, this is definitely not the right signature. On upload handler function, no. Okay, so it's actually like this. Ah, okay, there is a body handler function. There's the signature I was looking at. So let's do this. Yeah, maybe we should copy this one out, this signature, because why not? Why not? So there we go. There we are. So now, if I understand this one correctly, we will get the total upload size, and we will get, let's check this. I guess we will, yeah, exactly. Len is what we are currently getting. Then there is the, this was here, I guess. No, it was, sorry, there. It was there. Yeah. So yeah, exactly. So we are getting a total number, and then we are getting what's currently in this chunk, and index is simply where we are currently at. So okay, this kind of makes sense for me. So if index equals 0. So this is beginning of body. Then we should have a pointer here. I guess can simply do a void pointer, which is our body data, body pointer, body. We could simply call it body. So, and for now it's the null pointer T9. No, it's null. There's null pointer. So what we are going to do here is I guess we are checking if body does not equal null pointer, because if it does not, it is already allocated. So we need to free the body, the last body, whatever, and then we are going to body is ps malloc. We could of course reallocate it, but I don't really see why we should do this here. So we are allocating it with a total body size here. If body is null, we are answering with a body memory for body could not be allocated. We will simply send this one back and return from the function. So Yeah, however, then the following chunks of this thing will... Yeah. I guess we need to do something like this here. If we are not in index 0, if body is equal to null. Yeah, we can actually, null pointer and null should actually be identical, shouldn't they? Yet a different type, I guess. So let's just use null here for both. It makes things easier for us. So if body equals null, I guess we are simply skipping this chunk. So skip further chunks if initial allocation failed. Something like this. Okay, so now we have our error, done our error check. So we should have enough storage space there to actually store our body. So we should be able to do a mem copy where we copy to our body storage. Actually, this is something we need to do for every of the chunks. So, oops, sorry. We need to let me format this. There's something wrong with the indentation. We need to mem copy to body plus index. Yeah. And we need to mem copy what? We need to mem copy data. And we need to copy len. So this should actually do the work for us. So if we now check if index plus len equals total, we are finished here. Body is complete. So we can maybe do a request send for now 200 no 200 text plain, and then do something like yeah, maybe we just give the body back here. Let's do this, and let's call this not render color, but let's call this echo for now. So I'm not sure this will work, but let's check. Let's test it. Okay, this does not work, of course, because conversion of argument 1 would be ill-formed invalid conversion from void to const char. Yeah, does make sense. Let's make a reinterpret cast const char there. PS3 was not declared in this scope. Okay, isn't there a okay, there is. And PS3, is it, I guess we simply free the pointer then and he knows where he allocated it. Let's check this. Warning, void of type used in arithmetic. Yeah, I know, but on the other hand, I know it should point to the right thing, so yeah, maybe we can do this better. Okay, so yeah, okay, so this is working. So let's get back to our thingy here and let's check if it's wrong terminal, I guess. Not the one I was looking for. Ah, no, that's not what I wanted to have here. This one can go, and let's just curl x host. Let's directly try it. 168.41/echo. And I guess it is data raw. I'm not 100% sure. Hello world or something like that. Okay, does not work. Empty reply from server. So what has happened here actually? Maybe we should have, we should maybe have some output here. Serial, print line, print, or let's do it with logd, I guess. Yeah, come on, that would be easier. Where are we? We can actually do something like this here, but I guess it wouldn't want that either. No, let's do it this way. So, okay, so we want the, where are we? There is the body, so let's move that down for a second. So, okay, let's have some log statements here. Log D. Let's log. What do we want to log here? Body chunk received. Received. So we want to have len, which is obviously a decimal. So then we want index, which is a decimal as well, and we want total, which is a decimal as well. Come on. So now we want here like len, index, total. So for now, let's check if it's receiving anything at all. Let's check. Let's wait and let's check. And oh, it's gotten quite dark in here actually. Yeah, I need some more light here, definitely. The problem with it is I can't actually make it now brighter here because the server which controls all the lighting in here has just crashed before I started the streaming session. So I have to take care of that once I've ended the streaming session. Maybe I can have the camera get a little bit brighter, but it won't actually increase the quality of the image. Yeah, but it should be a little bit better this way. So okay, so yeah, there we are. We have the output. So let's send something there and let's take a look. Okay, it's not. Okay, that's kind of strange. So maybe this data raw is not right. Man, curl data. I know that there is. There is at least a data binary, exactly data binary, data raw. This post, but without the special interpretation. Okay. Yeah, but don't really get it. Why is it not processing this? That's kind of strange. Data default content type. Okay, maybe it's. But even so, if it's sending the application from encoded header, shouldn't be a problem at all. I mean, I can send this header or even anything else, but I don't think that the async web server is handling this on its own. Kind of strange. that it doesn't even reach this this call. It's kind of strange, I guess. Let's echo request received. Let's check this. So just to make sure there isn't something very strange going on. So let's upload this. And then it might work. Oh, it's starting to rain outside. Nice. So it means it's getting a little bit cooler, which I actually like. Because it's been very warm in here. So I can most likely just let some cool air in later on. So, okay. No. There we go. Data binary it was. Okay, it seems to me like echo request received. So it means that this one was actually called, but okay, let's check if we put in there this one. Okay, then something very strange happens because I sent quite some. Okay, this looks like it hello world or something like that, and then yeah, of course, because I'm not. I have no zero termination here. So is there any variant of this one which allows me to give it a size? It actually expects a string here, file content, stream, content type, len. Okay, I have to check this. Maybe there is a variant I could use for this. Okay, so we have content type. That's the one we are currently using, but we don't really. We have now the content type, the len, the response filter callback. No, that's nothing I want. So there is a stream. No, I don't want that as well. We don't have a file. No. Okay, that doesn't look so good. So maybe we should just do the following. We allocate just 1 byte more, and then we are doing a mem set where we are telling it to set this one to zeros, I guess. So total plus 1. So we will actually then have a zero terminated string in there. Shouldn't be a problem anymore, and it should be able to output it properly. What did I do? What did I do? What did I do? Yeah, I totally missed the semicolon here. So obviously the ESP async library does something kind of strange or special if we are sending URL form encoded data. Maybe it automatically decodes it? I have to check that. It's kind of strange. But yeah, could be. Don't know. Let's just check if it's yeah, okay, it's answering. So yeah, okay, that works. We are actually getting our sent data back. So I like that. We should actually, if we now have the serial monitor open at the same time. Well, wait a second. There we are. We should actually see that it is Yeah, it is actually getting data. So interesting. It is receiving the chunk before it is calling this. Okay, that actually makes sense, that it is waiting to receive the chunk and then it is calling our handler. So maybe we could do this handling here, which we are doing, this answering. We could actually do it in the real handler function. Would be a lot cleaner this way, I guess. Okay, now let's check what happens if we are sending something that consists of multiple chunks. So we need a lot more data here. So maybe we can just generate some data here for I in sequence 0 to 1 million. Do echo line I to test data. Done. Okay, I wouldn't have expected it to take this much time. Okay, we have 3.5 megabytes of data here, which should be... Let's test data. Yeah, okay. Interesting. I wouldn't have guessed that it would be that much. Okay, so but this should fit actually in the PS memory, so it should be an okay test for what we are going to do. Let's do this data binary, and we can now specify here with an add that we want we want test data, and it should actually do this, and then we would answer data, put it there just in order to be able to check that we have gotten back everything we sent. So that's kind of really slow, but it is a lot of data that is going through there. And yeah, as we can see, this thing it's receiving the data in 1.4 kilobyte chunks, actually. Interesting. Yeah, and what it's making it so slow is actually that we are logging out each of those requests. Yeah. That makes things really slow, as serial communication is synchronous, I guess, inside the processor, at least the way we are using it, and we are using a 9600 baud connection, which is so maybe I just thought I would let it work, but maybe we should just come on, we will, I guess we can have it a lot faster, really, if we cancel this here and reflash it without the lock output there, because it really makes things a lot slower than they need to be. It should be a lot faster after. A lot. Because the ESP actually isn't that slow. It's quite fast processing information actually on the Wi-Fi. It's a microcontroller nevertheless, but it won't break any speed record, but it's not that slow. So yeah, as we can see here, it's a lot faster now. So there we go. So now if we do let's have a cut at answer data, which is nothing, and that is not good. Not good at all. Okay, something went quite wrong there. Why? Yeah. What was that? Why didn't we get any answer at all? That's kind of strange. So we are not getting back any information there. Why are we not getting any of the information back? Because essentially we should have filled this up. We are actually trying to allocate total +1 memory here. And maybe we are let's just generate a little less data for testing here. Let's just do 1,000 lines should be enough. Test data. So yeah, now we have what do we have now? Come on, we have now about 8.7 kilobytes. That should actually split into more than one chunk. What I wanted to test. So yeah, this should work. Okay. Let's do this, and then we can actually re-enable the chunk logging here as well, and maybe we can do some more logging, like do we want to log that? Yeah, why not? Log D, freed old body memory, and then we go there and we say, okay, so maybe this wasn't triggered. Maybe let's check if we have something strange going on here. Like log D index plus len. No. Index plus len equals D equals total equals, no, like, let's do it like this. Should be better readable. Yeah. Come on. So there we are, index plus len, and we want the total, and we will get that and put it just here. So yeah, so let's upload this and check again what's going wrong there. Yeah, actually, in all of these projects I'm doing, it's kind of it's starting quite slow, and then it is, once you have all this basic infrastructure in place, it's usually going quite fast. But we have to figure out certain basics here before we can really start, like getting data to this thing, and yeah. So let's check this out. Okay, now we get the data back, which is kind of strange. Maybe there was something regarding the... let's check answer test or something like that. And let's just diff unified test data and answer test, and let's check that. Okay, they are the same. I just wanted to check that we don't have something strangely going on here with regards to the pointer copying and stuff we're doing here, that we are not somewhere missing a byte or something like that. Okay, so freed old body memory, which is kind of strange because okay, we did it 2 times, right? So yeah, we did it 2 times. Okay, so yeah, of course it freed the old body memory, it allocated new one, and then yeah, okay, that seems to work quite well actually. So yeah, maybe it just was a fluke before. We will definitely have to test it with bigger files, but I guess we will automatically get to this once we are uploading images. Hopefully doing that in the next stream. Yeah, I'm not 100% sure when the next stream will be. If I have time, somewhere next week, because I'm quite eager to get all this working now as well. So yeah, I hope. Yeah, it's the lighting conditions in here are really worse. So sorry for this. I will promise to try and fix this for the next time. And I even have some front lighting I could put here to have a lot better quality. But yeah. So yeah. Actually, what I was going to say. There seems to be some sort of internet connection problem again, or Twitch connection problem now that I'm looking at it. I hope it wasn't the whole time. It's currently not putting through much of a stream there. Okay, there it is going again. Hopefully it's working again, and hopefully the stream was kind of constant. Yeah, internet sometimes gets kind of flaky around here this time of the evening. So where was I? Yeah, I will most likely be streaming next week again. I'm not 100% certain when I will have time for it. When it will be, I will announce it via Twitter, definitely, and via Twitch, of course. So if you are interested in stuff like this, please subscribe, and we can work on this together and find out what's going on there and what we are building in the future. So yeah. So thank you for watching, and definitely will be back next weekend if I don't get it in the meantime. And yeah, I will prepare to push this code and repository to GitHub, some renaming and restructuring the folders here regarding platform IO to do. I will do this in between streams, not live, because it's not very interesting for you to watch. So yeah, I hope you had fun as much as I did. I will definitely go on with this, as I am having much fun, and I would build all this stuff anyways and figure it out. So it's quite nice to do this with an audience. So yeah, have fun, have a nice week, and I really much hope to see you next time. Bye.